Welcome to this SAP Tech Bytes video. The other day I received a question that had to do with a situation where a user had a HANA development project in the SAP Business Application Studio. They had created it as a pure HANA project in a HANA dev space, and they had created their tables with like HDB table, HDB view, maybe they had calculation views and stored procedures. And they were at the point where now they wanted to add service enablement to that project. In the Web IDE, you could have just ran a wizard that would have added a Node.js module with the XSJS compatibility layer or XSODATA, but we no longer recommend that approach nor support XSODATA for HANA Cloud. Instead, we deliver superior functionality using the Cloud Application Programming Model. But the process of moving from a pure HANA native project to a Cloud Application Programming Model project is quite a bit different than, say, what it was in the SAP Web IDE. So in this tech video, what I'd like to do is take this exact customer scenario, got a little HANA only project, and we'll see the steps that it takes to convert that to a CAP project, and how you can use all those existing artifacts without having to completely remodel them in CAP. So what we're seeing here is my basic HANA database project. Now, I've chosen to work in Visual Studio Code with certain SAP extensions installed. Basically, the same steps and experience would work in the SAP Business Application Studio as well. In fact, to make sure everything was compatible here, I actually went and created the project using the HANA database wizard in the Business Application Studio, then pushed that bare bones project to Git and cloned it to my local device to continue developing. So it's a matter of preference here, but I'm gonna show you all the steps here from Visual Studio Code. Very simple project. If I look at my mta.yaml, I just have a database module. I've got my HANA HDI container resource, HANA PO. I have already created that. So like if I look at the HDI containers that I have in my space in Cloud Foundry, you see the HANA PO HDI container instance is already created in the HANA Cloud database. I'm using HANA Cloud for this. If we look here, what do I have? I reused an example that I already had out there with a purchase order header created via HDB table, a purchase order item created via HDB table. I do have, I have some views, but created via HDB view, and I have a constraint. I also have a calculation view, and I've got a stored procedure, just to kind of cover all the different types of artifacts that you could have in a project, but minimal scope here just to get me going. I do have HDB table data and some CSV files to load some initial data into my database. And just to show you here, from the simple HANA database project, if I just go to the DB folder, npm start, we'll start the HDI deployment into the HANA database. I've already deployed this once, but just to show you the process here, I didn't actually make any changes because there was nothing new or different. And if I now open in OpenDBX to open the Database Explorer, which opened on my other monitor, over here. And here is my HDI container in the Database Explorer, so we can see what has been already deployed. For instance, we've got PO header, PO item table. There is some data already in there. Maybe for instance, I'll show you my calculation view. I've got one simple calculation view here. Open data. Look at the raw data, for instance. And there's my calculation view. Just to show you what's in the project so far. Oh, I guess I should show you. I do have a stored procedure here, get PO items. Really, I probably could have done this with a view, but I wanted to demonstrate the mechanics of also calling a stored procedure from CAP. So that was the main reason for including this. So we'll just go ahead and run that, and you see it does some calculations, some internal logic, and then returns certain purchase order data as well. Okay, so just to show you, it's all deployed to the HANA database. It is a HANA database project. So at this point, we want to begin converting this to a cloud application programming model project. Now, I could run this directly on my project, but I think to be safe, what I want to do is I want to make a copy of the project. So let's just say copy SAP TechBytes public. That's my current project name. And I want to make a copy of that and call this existing cap 2, because I already did this once locally. So I'm just going to make another new copy, and I want to do a recursive copy. So that should take just a second to copy my entire project. There we are, and now let's load the new project in VS Code. Nothing's changed, just a copy of it in a separate folder. But now what we want to do is we want to go ahead into this folder, and we want to use the cap development kit, so the CDS command, and say help init, so CDS init, and we want to make this a Node.js, so add Node.js, and CDS init add Node.js. And it added the feature Node.js to our project. So you see it created an SRV folder, nothing in it yet. It did add a package JSON at the root and structured it for a cap project. So we're kind of well on our way here to having a cap project, but it did not adjust the mta.yaml. So we're going to do that in a second with a second step here. Let's actually close that. Because what we're going to want it to do here is we're going to want to say CDS add, and we're going to want to add HANA and MTA to this. And it says, okay, the folder already exists. Are you sure that you want to overwrite the content? Unfortunately, it doesn't merge the content together with, say, the MTA that already exists there. It's just going to overwrite it. But that's okay for our purposes. We'll go ahead and say force. So it kept our database folder the way it was. So all of our original content is still in there. But what it did do is it overwrote our MTA YAML. So it added the Node.js module to our MTA YAML. That's good. It overwrote the database module. But the main thing that we want to do here is, if you remember, what was our container name? It was hana-po. It didn't know that. Couldn't know what our name was. So we just want to come back here and we want to give it the same name, because we don't want to create a new HCI container instance. We want to use the one that already existed. So we'll just change that in those 3 places. And that's it. We now have a cap project converted from our HANA database project to a cap project. Now, it's not quite ready to go yet. We've got the basic project structure. It's in good shape. We can do things like now that we have a package JSON here in the root with basic requirements, and it is pointed. Oh, one other thing here. I'm a little surprised it didn't change that from when we added HANA. Change that from SQL to HANA. I want to go ahead and do that. But now that we have those things done, we can run an npm install in the root, and that will install the cap dependencies here, the CDS Express and the HANA client in the root of the project. But what we need to do is we need to now pull our artifacts, our database artifacts into CAP. Right now we have no CAP model, we have no CAP services, so there's nothing for the Cloud Application Programming model to really do. We need to add those things. So I want to come here to the root of my database module, and I want to begin creating a CAP data model. So we'll just create a new file, call this model.cds, and actually I went in the, we want it here in the root of our project. And, normally you would start defining entities, right? But we don't want to recreate the entities. They wouldn't necessarily have the same name, same structure, and things like that. We want to reuse the entities that are there. So in order to do that, what we did, first of all, let me show you. I took the data model, we had like header HTTP table. Now there's some names here that don't comply with the naming standard of CAP. So the very first thing I had to do was create a view on top of the table. There I go. It's right there so I can look at these side by side. So I created a view on top of the table, but notice it does not have with read only. So this is going to be a view that's going to allow insert, update, and delete as well. What it's going to do is just basically put aliases on top of the various column names. For instance, we took the history.createdby.employee ID from our original data model, and we put underscores in there so that now the name, all the names will comply with the CAP standard. And what I can do is I want to create a proxy entity. I have to basically create an entity and use a special annotation called CDS persistence exist. And then CAP won't try to recreate that entity. It won't create a table or view in the database. It'll reuse the existing view. But it still needs to know all the data definition of all the columns in the table. We can't just import it from the database, unfortunately. But the HANA CLI tool has an option here to say inspect, let's do it, inspect view, and we want to inspect the output to be CDS, and we want our view to be PO header view. And what that's now doing is it went to the database and it read all the information about that view and it brought it in here in CDS format. And we could take this and we can just cut and paste this into our model CDS, and it's going to create this proxy entity that allow us access to the underlying tables without having to recreate them or remodel them, move the data or anything like that. Now what I've done is I've already done this for 3 of my entities, so I'm going to just cut and paste that. So we've got the PO header view, I've got the PO item view, and I got my calculation view as well. And I want to expose all 3 of these via CAP. I want to be able to do create, update, delete operations on the header and item, and I want the calculation view to be read-only. I've just created these proxy entities. That's all we have at this point. Now, if I were to come here and do, let's try this. Yes, build from the root. Yeah. What it does is it creates its output in the gen folder and create this DB source, and then you see inside there. It didn't actually create anything in gen inside the DB folder because these entities don't get created in the database. We're telling it because this annotation CDS persistent exists that it doesn't actually need to do anything with this in the database, so it didn't generate anything, but it did copy over our existing database artifacts. So now from this gen.db folder, which is also where our mta.yaml is going to run from now, gen.db instead of just the db folder. But this gen.db folder, if I cd into gen.db, I can run an npm start, and it will run the HDI deployer. Because CAP has now merged all my original content with any content that it generated, I've got a new database deployer. that gave me an error there. Oh, it messed around with my configuration there. That's interesting. When I did the CDS add, it kind of looks like it maybe broke my configuration file. It didn't have an HTTP view in there. That's okay, because I can fix that with a hana-cli create module. That will rewrite the HDI config. And now if I do a CDS build, oh, I'm in the wrong folder. Let's go. Oh, no. No, I'm in the root. I'm all right. CDS build. I'll put that into gen. And this time, I'm relatively confident. GenDB. Boy, I cannot. There we are. Now I'm in the GenDB folder, and I do an npm start. And this time, like I said, relatively confident that the deployment will work this time. There we are. All good. So now I've both converted my database project to CAP. I've added my proxy entities, and now I have a build that works to deploy to HANA database, but via the CAP project structure. All right, so we're doing this because we want to most likely have an OData service as part of our project. So let's go to the SRV folder, and let's create a file here. Just call this model srv.cds. This is going to be how I expose my service. So, cut and paste this, but basically going to import my three entities from my my model. And I'm going to create an OData service. I'm going to name it PO service. I'm going to expose my calculation view as read-only, and then the header and the item table. And I'm going to expose a function that we can map to our calculation view. Now, the entities will be generically handled. So create, update, delete operations, all done for us. Even though it's a view underneath there, we don't need to implement anything. There's no exit handling, but a function or an action that we then in turn want to call, say, a stored procedure or something like that, we have to implement that. So we're not going to get that immediately, but this is going to be enough to at least model our project and get the entities going. So now if I back up here and do a CDS build again from the root of my project, it should pick up this new model SRV. Yes, so now I have it in my gen folder. Now I have an SRV folder as well. And it's got like the CSN of the service. So that is pretty much ready to go. You know, copied my root package JSON. So, you know, that's all looking good. But it also added something. Now, if we go to GenDB source gen, now we're seeing some views, because when you create a service definition in CAP, it does generate HANA database views as well. Now, those views, those generated CAP views, are merged into the same DB module that already had my native content in it. It all lives together just fine. You just have to be sure, before you test this, to go to GenDB and do an npm start to deploy this into the database again. Because we need those views for our OData services to work. There we are. It's done. Those views now exist, and if you want to test that, you can do a hana-cli views, and it will list all the views in our container. And now you see we have these PO service views added into our container as well, in addition to the existing views. Okay, so now from the root of the project, I can just do a npm start, which will do a CDS run, and it kick off our project locally, although we're connected to the remote HANA Cloud database, as you see here. So, you know, we're getting a nice real test here. And it launches the CAP test page. Here's our OData service. For instance, I can read the metadata of my OData service. Very nice. I can go to my calculation view. There's the data from my calculation view, or from my purchase order headers, or from my purchase order items table. And I'm not had to do any migration. I haven't recreated the tables. The tables and views are all still what was there from my original HANA native project. Those artifacts are still defined as HANA native artifacts. They are not redefined in the cloud application programming model. We just built like a bridge view on top of them so that CAP can expose them automatically via OData. And it does support full create, update, delete. I'll show you that in a second because we're going to add a couple more features to our project. But this is the basics. You know, if you want to know how to convert, you see, follow these couple of steps, and boom, you've got a full OData service based upon CAP without having to make too many changes to your project. But in an optional little extra part here on the end of this video, I'll show you how we can further enhance this and also call our stored procedure as well. All right, for this last part, I want to take you through some optional things that I've added now to our project. So first of all, in the package JSON, I've added a couple of more modules here. Let me stop this. So I added the CDS development kit. We'll use that in a second to compile our project dynamically to openAPI. So we can add a SwaggerUI onto it. I added the SwaggerUI. This is going to give us an additional test tool that we can use. It's particularly nice for testing create, update, delete operations on our OData service. And I added the V2 proxy adapter. These are the main things. I also added the HTTP EXT module and HTTP EXT promisfied. That's going to help us call our stored procedure from an exit handler. Now, the main thing that I did is I added a file named server.js. Now, this is the name is sort of automagical. If you create a file named server.js in the SRV folder, then it overrides the bootstrapping of the cloud application programming model itself. Now, there's quite a bit of code in here, and most of it is taken right from the online help because there's been the recent addition to CAP to be able to compile to openAPI and use Swagger as a test tool. And this is just mostly the logic to add the SwaggerUI to the CDS test page output that you're going to see here in a minute and to compile to openAPI so we can test it. That's all this logic here, which, like I said, I cut and pasted right out of the online help pretty much. Then the other thing that I added is right here. I added a section to call the OData V2 adapter proxy to also add OData V2 to our service. So maybe if you're converting a HANA database project, maybe you don't need OData V4, which CAP has by default. Maybe you actually want OData V2 to be backwards compatible with XSODATA. So this line of code will give you that. And then I added another additional handler here for a pure REST service. If you don't want OData at all, but you want just plain REST without the OData, CAP supports that as well, and I'm telling it here to load this service and expose it via a URL named just /rest. The last thing that I did to the project was I added some exit handlers. So just like in XSODATA, you can have exit handlers, and you trigger them by creating a file with the same name as your CDS model, just with an extension .js, and then it will automatically be loaded as an exit handler. And I implemented two handlers. I used an after create, update, delete for the PO headers entity. And this is how you set it up. You tell it what actions, after, on, or before, what operations, create, update, delete, read, and what entity. And then this logic will be triggered by CAP automatically when these criteria are met. And in this first one, and whenever there's a create, update, delete on PO headers, I just want to raise an event with the ID of whatever record was just processed. So kind of a typical exit handler thing you might do. This other one is specifically to call our stored procedure. So as I said, CAP will have generic handlers for entities, views, tables, for create, update, delete operations. But if you want to implement a function or an action, you have to code that yourself in an exit handler. So I'm just saying this on get PO items was the name of the function that we defined in model SRV CDS right here. And the implementation of this is basically to connect to the HANA database and use the HANA database client, the extended version of the client, to load a stored procedure named get PO items. Wouldn't have to be the same name as our function, but I kept it the same. And then I'm saying call that stored procedure. It has no input parameters, but then take the output and return it as the output of my function call over OData. So let's go ahead and run this project now that we've added these things to it. So do an npm start. Now you do have to do it because I added more modules to my package.json. Don't forget to do an npm install to actually download and install those. I already did that off camera because it takes a couple seconds to bring everything down. And it's not terribly exciting either. But now if we test our application, when I bring it over here, you'll see right away I have two endpoints, a REST endpoint and a OData V2 endpoint. And you see this new SwaggerUI preview. We added all this stuff to the standard CAP page by using that additional bootstrapping logic that I was just showing you. So for instance, like if I come here and I look at the metadata document. So first of all, version 4, OData V2. But if we just add to our URL a V2 into the URL, then what you're going to see is this is now OData V2. So with that little proxy adapter, you have the ability to support either OData V2 or OData V2, which, like I said, it might be nice for XSODATA backwards compatibility. We also have the ability, like if I run this here and look at the PO output, it's pretty clean. I mean, the OData standard returns JSON now by default, but you do see this OData context here at the beginning. And if we look at the REST version of the service instead, it looks very similar because it also returns JSON, but no OData overhead, no additional OData metadata or structuring. Okay. While we're in here, let's try to call our function. So you just add that onto the end of your base URL, get PO items. That was the name of the function. Open close brackets. And when I call that, it executed the stored procedure behind the scenes, called my exit handler, and returned the data. And you don't really see much difference, for instance, between this and calling the entity, because our stored procedure was really just querying from the database. But we could use calling a stored procedure to do anything we want, whatever logic we want in there, very complex logic we could access. But then it's very much like any other entity the way that we interact with it here. And then finally, I want to show you the SwaggerUI that was added. This is a relatively new feature of the Cloud Application Programming Model that it supports this additional functionality. And what you see here is you get a nice entity map of your CAP model, and you get this test tool that allows us, for instance, here I can come here and I can test out my OData service, all the different OData options, run it right from here and get data back. But what I want to do is I want to use this to test the post operation to create a new record. So I'm going to say try that out. And actually, let's just get this up. Give it a new record number and what? All this. I think it's probably going to. Let's see. Execute that. And I did a post. I'm not. Let's try that again. I'll change by employee ID. It's not in my view. Let's take those out. Let's just get this down to a minimum here. Probably pick a very good, there we are. And we see that it has created the record in the database. And if we go back, we can also see that it emitted our change. So we know that our exit worked. Go back to our exit handler. So we got a create on PO headers. We see that it output our emitting PO change. So we know that it emitted the event. So we know that our exit handler worked as well. And the SwaggerUI gave us a nice way to test that. Before you might have had to use Postman or create a Fiori UI in order to test update operations. But now you can use this built-in SwaggerUI to test here as well. Now, a little optional bit there at the end to get a little fancy, but hopefully this helps you in converting your existing HANA projects to add the Cloud Application Programming Model to them. All the source code is available in GitHub in the SAP TechBytes repository. I'll put a link to that in the description of the video. So feel free to study the code in more detail directly there in the repository. And this is actually a two-part video. In the next video, I'll show you if you didn't want to use CAP, but you did want to expose HTTP endpoints, how you can take your existing HANA database project, just like we did here, and add just a pure Node.js model to it and code it all yourself without the use of the Cloud Application Programming Model.